Hey guys, this is Carrie, and in this video we are going to be making a number guessing game that you may have played with your parents when you were growing up, or with a younger sibling when they're growing up. So first off, exciting new news. If you go to repl.it, they have updated the URL to replit.com. So all of my videos are now out of date, and hopefully they maintain both URLs. But for now, you can start using replit.com in order to get to it, although repl.it will redirect for at least some time. All right, so that's exciting for them, but what's exciting for us is we're going to be making a new project. So it's going to be an HTML, CSS, and JavaScript project. We'll call this number guessing game, and it's going to be number 1, because I think we may make the reverse style of this guessing game shortly. So in this version of it, the computer is going to be thinking of a number, and we're going to try to guess it. So today we're actually going to be working with a new programming tool. So to make things simple, we're going to not edit the HTML at all, not edit the CSS at all, but we're going to do everything through the JavaScript, since we're just focusing on functionality. So we are going to make a number guessing game. All right, so to think about our number guessing game, it's going to work the same way that maybe, like I was saying, you've probably played this game 1,000 times with your parents or something growing up, and maybe it was a really interesting game when you were growing up. But it's a kind of simple game. So the computer is going to think of a random number. And we are going to keep guessing until we get it right. All right, so we've got kind of a sketch of the program, and I like to do this in my head before I start making these videos. Oftentimes I'm like laying in the couch or trying not to get out of bed, and I'm thinking, what should we program for computer science? And that's usually when I get a sketch of these ideas about like how we're going to incorporate the new functions. But then it's really useful for me to type out the steps, because now we can just fill it in programmatically. So there's kind of a phase of design here. You get an idea, you type in the steps in English, and then you transfer the steps over to code. So whenever we want to generate a random number for our computer, we're going to be using our generate random function. So let's grab that and put that here. You'll notice that oftentimes we begin our JavaScript by selecting the elements on the page we're going to be interacting with. We're not going to interact with any elements on the page today, so we're not going to do that part. Now for the computer to think of a random number, we have to create a variable. So let computer number equal generate random. And let's go 1 to 1,000 to make it hard for the user to guess this. And let's see. Maybe before the user starts guessing, we should give the user some instructions. So we're going to be working not on the HTML. We'll be using those pop-ups. So remember, those pop-up functions that we learned way early on were alert and prompt. And I'm not saying equals in the traditional sense of programming here, so maybe I will just use like a colon so that it doesn't confuse anything. These aren't code statements, these are statements just to remind us. So to give the user some instructions, let's use the alert function, because we're going to be outputting info. I have thought of a random number from 1 to 1,000. Guess my number in as few moves as possible. Good luck. All right, and now I've accidentally here made the game more complicated for myself. I said guess my number in as few moves as possible. So it does look like we should be keeping track of the user moves. So up here, let's also initialize some other useful variables. So whenever we initialize a variable, that's what we are doing here. Initialize means hey, we're going to be working with a number called computer number, so create a space in your memory for computer number. That's initializing a variable. And then here we say, okay, in that space, store a random number from 1 to 1,000. We're going to initialize some variables here. So one of them is going to be the number of guesses. And you'll notice that I'm using camel case, which is the first word starts lowercase, but then each subsequent word starts uppercase. And that's the way a lot of variables work in JavaScript. Okay, so let number of guesses equal 0, because at first we haven't taken any guesses. And in structuring the code here, it's actually really useful to, even though the user hasn't guessed, it makes the code a little easier later on to just say, let guess equal. And because they haven't guessed, we don't want to guess an actual possible number like 500. This guess may actually be right. What we're going to do, though, is we're going to start their guess off with something that it cannot possibly be. So something like -1. We know the computer is thinking of a number from 1 to 1,000. So we'll create the user guess to be -1 to start. And basically, this is like a placeholder because they haven't guessed yet. All right, so here we go. We have the computer's number. We've taken 0 guesses. The user's guess is not entered in yet, basically. It's -1. It's not possibly going to be the answer. And we've alerted out to them the game, basically. All right, so here we go. It's time for our while loop. So we're going to keep guessing until we get something right. So while our guess is not equal to the computer number, run this code block. And this should remind you a lot of if statements, right? If this condition is true, we do this. While this condition is true, we're going to do this. So the big difference between if and while statements is if statements run once. It checks once. A while statement will keep checking over and over again every time it runs the code block to see, hey, is their guess equal to the computer number? Okay, so while their guess is not equal to the computer number, what we want to do is we want to allow them to have a new guess. So let's make their guess equal. And you'll notice that we don't use let here. Part of the reason why we don't use let, or why we defined guess up here, is so that we would be able to constantly update this variable without recreating it every time we were in the while loop. So here, what we're just going to do is we're going to reassign their guess to their prompt answer. So prompt, take your guess. Okay, and then what else do we want to do? We want to update the number of guesses. So now they've taken a guess, so the number of guesses will be equal to the old value of the number of guesses plus 1, because they've taken one more. I forgot a semicolon there. And now I think what we want to do is we want to give them some feedback about their guess. If the guess is equal to the computer number, then let's announce out, so with an alert statement, you guessed my number. It was, and then we'll plug in what the computer number is using the plus signs for string concatenation. And then we'll add an exclamation point, and then we'll say, it took you number of guesses plus the word tries. And it may take you some time to get the spacing right and the plus signs right here. If you leave out a plus sign, it will tell you an error like unexpected token or something, I think. I'm not quite sure. Unexpected string, maybe something like that. Just make sure that when you're adding these strings, you have this part plus this number plus this string plus this plus that. Every time you separate between things, you need a plus sign. All right, so if they guess it, that's going to happen. Now, it's not going to be a very fun game if we don't give the user any feedback about the quality of their guess if they didn't guess it. So let's run an else if here. And let's say if the person's guess is greater than the computer number, then we want to alert out, wrong, your number is too large. And if if our guess is less than the computer number, then we want to give them some info as well, which is to alert out, wrong, your number is too small, like your brain. Mean computer. All right, so let's see. This is getting kind of complicated here, but the logic should make sense to us, I think. So let's just outline it. We're going to keep guessing until we get it right. So that's the while loop part. This is going to keep running as long as their guess is not equal to the computer number. And that makes sense, right? When you played this game with your parents, you'd keep guessing until you got it right. In order to guess, though, each time, we need to make their guess equal to the answer to take your guess. Number of guesses is equal to number of guesses plus 1. And actually, you know what? To make this game, to make this game easier to do at first, I'm going to do a console.log of what the computer number is. And this will, for testing, that way we can test this out. Okay. So if their guess is equal to the computer number, then we'll do that. And these are going to check each time we're through the while loop. All right, let's just see what it is, because I think that will make it much more apparent. Okay, good luck. I want to open up the JavaScript console, and oh no, console.log has not run. All right, I guess I'm going to actually play the game here. Take my guess. All right, I do not want to reveal my actual strategy for this game, so I'm going to take some guesses. My number is too small. Okay, I will try 210. Number is too small. Okay, I'll try 350. Too small. 470. Too small. 513. Too small. 609. Too small. Wow. This is a big number this time. 803. Oh my god. 900. Okay. So that's wrong. So I know my number is between 803 and 900. 867. It's too large. So between 803 and 867. 843. Okay, so less than that. 830. So between 830 and 843. 835. Between 830 and 835. 832. 833. 834. You guessed my number. It was 834. It took you 16 tries. All right, and the number was 834. Great. All right, so I'm going to delete that part for testing because that failed. But you could see kind of the repetition quality of this from the while loop. It kept asking me for guesses as long as my guess wasn't equal to the computer number. And it gave me some good feedback depending on the quality of my guess. I want to see if I can beat 16 though. 16 seems really bad. So what you're going to be trying to do as you play your game is we're going to be trying to, I think, depending on what the interest level is maybe and how good of a project this is, we're going to be trying to design the opposite game in the future, which is, can you think of a number and then the computer guess it? So we want to try to come up with a strategy here to make our guessing efficient. And 16 tries wasn't a very efficient strategy. So I'm going to try again and see if I can beat 16. All right, let me go from the top down this time. So 950. Whoa, okay, I got really lucky. My number is too small like my brain. 950 is too small. I know it's between 950 and 1000. So 960. Still too small. 968. Still too small. 983. Still too small. 999. Great. Wasted guess. 999 is too small. Too big. 990. So between 990 and 999, 992, 994, 995, 996. Oh my god, that's crazy. 996. Picked from 1 to 1000, and that was what it picked. And you can see that that while loop is working really well. It's constantly checking, evaluating whether we've got it right. All right, so we've designed the game, but my strategy's not so good. So if you could play the game a couple of times against the computer and try to figure out what is the best strategy, I think it's possible. Well, maybe an interesting question is, can you invent a strategy that will always solve this in less than a certain number of moves? Like I don't know. Just invent a good strategy for the computer to use if we design the opposite game where the computer's the one guessing. All right, guys. I hope that was clear enough. The main part, program the app. The second part, create a good strategy for solving the problem. Bye.